we are going to start talking about our midterm exam. This lecture is specific to the fall of 2019. So if you're watching this in a different semester, this is not the correct video. Please let me know, and I will link to the correct video if that happens. But for the fall of 2019, we're going to be having the midterm sometime during the week of October 7th, which is today, until the 11th. And what I've done to sort of find times for that is I sent out a doodle poll to all of my students and got the times and the days that most people want to take the exam. So the earliest time that I have for anybody is on Wednesday, October 9th at 11 a.m. So if you're in one class, you can, I'm going to, no matter how many classes of mine you're in, I'm going to send you an email very shortly, and I'll give you 4 times that you can come to have an exam with me, and then I'll also send a Zoom link so that you'll be able to Zoom if you're not present. But in any case, the 4 times will be chosen among the most common times for students. And if one of those times doesn't work, you'll just have to email me and we'll set something else up. Now, of all of my students, 4 of my students are in 2 classes each. So you'll need to have 2 separate times. You also do not need to tell me which exam you want to take each time. So if you're in 2 of my classes, just show up for your first time and you can tell me right then which exam you want me to take, because I will have them all written. So also you'll have a choice between taking it face-to-face and taking it via Zoom. If you're here on campus, I strongly recommend that you take it face-to-face. It's much easier, and then if you have any questions, you can ask me. You can ask me on Zoom too, but it's still fine. It works fine. But if you're here, I prefer to see you in the classroom. We will take the exam not in this classroom, but in the conference room next to my office. The number is SM116. My office is SM117. So at the time, just come to that classroom, and we will get started. So the next part is, what is the exam going to look like, and what can you bring with you? Okay, so the midterm exam in any of my classes, so this is for my 3 classes that each have an online component and also 2 independent studies or finishing up classes. So for all of these classes, this is going to hold true. The midterm exam will consist of 4 problems, 1 from each chapter, and each is worth 25% of the exam. All right? So that's important, because if you are more comfortable with one chapter than another, you'll have an opportunity to display your talent and to get a higher grade. And if you are not able to do something, the other piece is that partial credit will be awarded. And my feeling about this is that means that I want you to show your work, because I can't give you partial credit for what's rolling around in your brain, although I'm sure it's brilliant, but I need to see it on a piece of paper. So that's how you get partial credit. Now, to get full credit, which many students can get an excellent grade without really getting a lot of full credit. But in order to get full credit, your answer will look, each one of these problems would look very much like the quiz that you took. I'm not going to write the instructions like do a free body diagram, state the problem, give me your assumptions, but I want you to do that format, and I know you're moving quick because you only have half hour per problem, but I would like to see that format, and then the final answer for a full credit would be a number plus a unit. I don't know, the appropriate number, the appropriate unit. But that's kind of the deal. But those of you that have had classes with me before, I think would agree that I award partial credit very liberally based upon your work. And the reason for that is I value arithmetic and I value algebra, but watching your problem construction is more interesting to me because I think that's what we're teaching right now. So the other point is, like if you don't have a constant and you say, I can't remember what pi is, so I'm going to use 3, I'm going to award full credit for that because, in my opinion, if you were working as a practicing engineer, it would be very irresponsible of you to not check those numbers. So I wouldn't think you would have them committed to memory, and even if you thought you had them committed to memory, I would expect you to go check before you created an international industrial disaster because you forgot how many pounds there were in a kilogram or something like that. So all of those things are available to you. I'm really interested in your thought process. And I feel from a teacher's point of view and from what I want you to learn to take forward with you when you transfer to university and then become a practicing engineer is that ability to work out a problem, to read something, and to translate it into math and pictures. So, and then to go down a good path in order to solve it. So that's really what I'm looking at. And so show me everything you have. Please also use engineering comp paper. I will bring some if you're physically with me in this conference room. I'll bring engineering comp paper, but I really like to see that. Okay, so what can you bring with you? Of course, that engineering comp paper. You can bring writing implements, pens, pencils, whatever you like to use. And you can bring a calculator, which is not internet capable. Okay. Now, one of the things that I always tell my students, those of you that choose later in your career to become a professional engineer will have to take an exam called the Fundamentals of Engineering exam. And this is a lot of colleges require you to take this course anyway, but this is put out by the National Center for Engineering Education, or for Professional Engineers, NSPE, and you are restricted to the number of calculators that you can use. So I do not ever recommend for anybody to I don't recommend for anybody to go out and buy a calculator, but you'll see that the list of calculators that are allowed on this exam are extraordinarily limited. And if you do buy a calculator, I think you should buy one of these because you're going to have an 8-hour exam that you want to be you don't want to be getting used to your calculator while the exam is going on. But that exam is the first step to becoming a professional engineer, which not all engineers do. But if you become a PE, you're able to work in responsible charge, and you don't ever have to, well, you really have to have a boss because, like, society is your boss. But technically, you're not going to have a boss down at the end of the hall if you don't want one. So it's kind of a nice way to live your life as an engineer. The other thing is some schools require you to take this. You do not have to pass to become an engineer. If you fail this exam, you can keep working. You can go to work and get a job as an engineer. You just have to pass this test and then proceed forward on the professional engineering path in order to work in responsible charge or to be your boss, your own boss. But anyway, so you take this exam with that calculator, then you practice for 4 years, you get some ethical, practice certain kinds of engineering, then you get some of your professional engineer colleagues to state that you're an ethical, upright person, and then you're allowed to take another exam before you become a PE. So it's a big process, but it's certainly worth it for most people. And the other thing is, it's not that scary. 70% of people who take the exam on a given day will pass. So I know people who have failed it the first time. I really don't know anybody. I know very few people who've not been able to pass it after a couple of attempts. Most people pass, but most people pass it on the first attempt. So and I should assure you, since I'm teaching you, I did pass it on the first attempt. So, which is good to know, right? Since I'm the person who's teaching you guys. So we want everybody to pass it on the first attempt. But anyway, calculator being the big deal right here. We want to make sure that you understand that. So I'm not as limited on that when I give an exam, just saying, pointing you in that direction if you do buy a new calculator at some point, not today or tomorrow. But that's what you want to aim toward. But in the meantime, non-internet capable. All right, the other thing you can bring is, and this is very important, you can bring a handwritten formula sheet with you. And that sheet must be in your own handwriting. And by that I mean you can't like photocopy little things or snip things out or anything. It has to be your handwriting. Also can't be in your roommate's handwriting, just yours. The reason that I insist upon that is it's a good study technique for you to consolidate your information. It's just time to kind of take a breath, sit down and look at the whole picture of what you've been doing and pull it all together, which is really a big part of the learning process. But on that sheet, you can put anything you want. So you can put formulas, you can put worked problems, you can put hints or techniques. You know, like for example, if you're a person who tends to forget to draw a free body diagram, put on there, don't forget to draw a free body diagram. So just whatever you want. Now, at the end of your exam, you will hand this in with your exam. I will give it back to you, but I need to see it. Okay? And once again, this is sort of a personal thing from my own time as an engineering student, but I had a professor who let us do this, and I just found it to be immensely helpful because when you're sort of running through the semester and really just hitting the high spots of stuff and just got 5 classes and you're just trying to balance everything, this can kind of pull you back into the essence of what we're doing in here. So you can bring all of those things. So the next thing is, since the exam will have 4 problems, 1 from each chapter, I would like to give you practice problems. And the first practice problems I will give you are for ES 2120 dynamics. And then after I finish those 4, on this I will give problems for ES 2110 statics. And then later I will put an addendum and I'll do mechanics of materials. Okay, so let's take a look at dynamics and let's just talk for a minute about what's going on. We started in chapter 11, and when we worked on chapter 11, the topic was kinematics of motion. So in other words, we were discussing how position, displacement, velocity and acceleration related to each other. And we also talked quite a bit about constant acceleration problems and the use of the kinematic, what are called the kinematic equations. Of course, all the equations we use are kinematic, but the ones that are specific to that constant acceleration are sort of lumped together and called kinematic equations. So we covered a lot of material. We covered different coordinate systems. We did some fixed and some inertial coordinate systems, and we also did some pretty classical problems. And I think in a problem in a class like this, I would like to do a very classical problem, probably a projectile. So I am looking to see if this one fits that bill. 11.188, which is in the review problems. A golfer hits a ball with an initial velocity at this angle. Knowing that the ball must clear the tops of 2 trees and land as close as possible to the flag, determine that velocity and the distance d when the golfer uses a 6-iron with this angle and a 5-iron with this angle. All right, so 188 looks like a great problem. I don't think I would put so many criteria on that. If you look at problem 188, just briefly, what we're doing is we just have some criteria to meet. So in other words, we launch here, we have to get high enough to clear this, and we can't have dropped off enough to not clear this. So we take those 2 points. That's a little, it's not difficult, but that's a little bit much for a problem on an exam. So I probably would just say something like, golfer hits a ball, this is the angle, this is the velocity, how far will it travel before it hits the ground? Or maybe there'll be a vertical wall, and you'll hit a vertical wall. But it's not going to have a bunch of conditions, okay? But that's a good problem to sort of pull together the things in Chapter 11. All right, then when we move on to Chapter 12, we talk about kinetics of particles. And kinetics has to do not with the way motion looks or the geometric description of problems, but more the forces involved. And in this particular section, we talked a little bit about orbital mechanics, and I kind of think that I may use an orbital mechanic problem if I can find one that is a little simple enough. One reason is because we use that normal tangential frame, and also because the potential energy is a little bit different. I'm looking at problem 12.130. It says the radius of the orbit of a moon is equal to twice the radius of a planet. Denoting by rho the mean density of the planet, show that the time required for the moon to complete one full revolution about the planet is this value, 24 pi over capital G rho to the 1/2, where G is the constant of gravitation. Okay, I would do something like this, looking for the period of that orbit. However, I would not put in a whole bunch of, I would give you numbers, because messing around with a literal equation can be a little trying under stressful times. So that will be some sort of an orbital mechanic problem. And you may be, I think you'll find good homework problems. I think the problems in the primer may be more helpful to you on that. All right, then chapter 13, we have kinetics of particles, energy and momentum methods. And this, the big takeaway in terms of problem solving here is that the momentum methods are all vector-based, and the energy problems are all scalar-based. So when you work with momentum, you have to be really careful about the directions of your vectors and conserving in those quantities, in those directions. Whereas with energy, you don't have to do that. You can just talk about the work energy principle or the amount of kinetic and potential energy. Okay. So I am looking at review problem 13.194. I'm going to read through this. This is a nice problem that kind of pulls those together. It's kind of a combination of a pool ball and a pendulum, so it's a pretty classical setup. What we have is a 50-pound sphere with this radius, is moving with this velocity, and it strikes a smaller sphere that has this radius that's hanging as initially at rest. Knowing that sphere B swings to a maximum height of 0.75 feet, determine the coefficient of restitution between the two spheres. I don't know if I'd go for coefficient of restitution, but I would have you back something out, or maybe I would say, if the coefficient of restitution is this, how high will it go? Something like that. But a ball hitting another ball, or something on a pendulum, where we're transferring energy in some different way. So this is an interesting problem because of all those things. All right. Then last but not least, chapter 14, where we're talking about systems of particles, and we're talking about those discrete masses and the fact that you can sum the energy and momentum behavior of the individual particles and come up with something that speaks to the entire thing. I like, there's a lot of problems I like on these. I like train problems. I like ballistics problems. Let's take a look at 106. It's a bullet being fired into a block. If the coefficient of kinetic friction between the block and the cart is this, and the cart has this mass, determine the final velocity of the cart and the block and the final position of the block on the cart. That's a good problem. Okay, there's a lot of stuff going on there, and yet you can tease out all that information, separate it out pretty quickly. All right, so those are the 4 problems for dynamics. And so if you are in statics or mechanics of materials, I'm going to do a short lecture that is an addenda to this lecture so that you'll be able to see what the problems are. We'll talk about the concepts in both statics and mechanics of materials. So those will be tacked on. So this one will be called Lecture 18. The others will be called Lectures 18A and B, and I'll reference which course we're talking about. But I want everybody to watch this lecture, and then you only have to watch A and B if you're in those other classes. They won't even be posted on your webpage if you're not in those classes. All right, so having said that, do you guys have any questions for me? Yes, sir.
The formula sheet, this is only 1 page?
Right.
More pages.
I know, I would like more than 1 page. Yeah, just 1 page this size, but you can write on both sides. And if you can write teeny weeny, that's fine too, okay? Yeah, it just kind of makes you, once again, it sort of makes you focus to do it on 1 page. But it would be nice if you had a lot of pages, but yeah, 1 page. Any other questions? All right, well, you guys just make my job easy, so thanks. And thanks for being here. It's a lot easier to present lectures when I have company. So I am getting used to talking to myself, but I prefer to not. So I definitely appreciate your participation. So I will send you an email later this afternoon, and I'll send just a number of times that you can come to take your exam, or to Zoom if you need to. And if none of those times work for you, just send an email back to me and we'll reschedule something personally. But I think I've got 4 times that will cover everybody or nearly everybody. So, all right, everybody, thank you for being here. And please let me know if you have any questions. And we'll see you for your midterm exam.